Bike radars at the Garmin Sharp Hotel. We're here to look at an extra special bike with Phil White from Cervélo. It's Ryder Hesjedal's Cervélo RCA. And Phil's going to take us through it, a little bit about the technology that's in it, and some of the ride qualities. So tell us a little bit more about the design in this bike, Phil.
Okay, well, the R series in the Cervélo lineup is kind of our classic road bike.
Yeah.
So it's a classic road, but it's where we put all the technology on as basically a technology demonstrator on the composite side. So it was really a work between our people in California and the guys in Toronto on developing this frame. And it builds on the squoval shapes, which are kind of a squared oval that we'd developed over, I guess, 2006 was the first version. This is generation 3. And it was basically an idea, can we improve on the performance of the last generation from a lightweight and stiffness standpoint. The last one was the lightest frame set in the world, according to some magazines, by 104 grams, and it was 30% stiffer than anything else. So this one we said, can we take the lightest frame in the world and make it lighter? And can we improve the aerodynamics of it as well? Because if we can do that, then we've got a really fantastic bike that loses none of the stiffness, none of the weight, but adds aerodynamics. So the guys in Toronto and California collaborated, and they worked on designing this concurrent aero and structural engineering process, and they designed the frames virtually. And this is the 95th frame, so they developed 95 different frames in an effort to optimize all those processes or those properties at the same time.
How many would you have gone up to? Would it have been an unlimited process? Would you have just gone up to 2,000, 3,000?
Well, at some point they had a deadline to reach, and I think this one was a little bit later than the deadline anyways.
Yeah, sure.
But engineers just are prone to constantly search for the best, and they'll keep going until you tell them, hang on, time out, 95 is enough. I think when we got to triple digits, that might have been their real threshold.
Sure. Okay, and the technology, obviously, from a technology point of view, there's a lot of work has gone into it. What about the aerodynamic properties? You were saying before that square or circular shapes aren't that good aerodynamically, but square you would think would be even worse. What makes a squoval shape so aerodynamically good?
Well, it's kind of funny. It was something that we stumbled across. When we designed the original R series with a squoval platform, we said the engineers had a mandate just make it the stiffest, lightest bike out there. And we didn't really pay attention to the aero side of it. And they did it, and then we put it in the wind tunnel, and just to kind of see how it compared to kind of traditional road bikes versus the aero road bikes, like an S series. And we found actually that it was better than a round tube bike. We were kind of confused initially because you said like it's square, what you would expect it to be worse than a round tube bike. But we found what happened was this isn't square. It was squoval, so it had rounded corners on it and kind of little convex sides, and those things actually made it more aerodynamic than a round tube. So we ended up just tweaking the shapes a little bit here, and you can see that they're different in different areas of the bike to deal with different aerodynamics. So it keeps all that lightweight and stiffness, but tweaks it in a few areas to get the aerodynamic benefits.
Yeah, sure, absolutely. And this frame, what does it weigh? What does it come in at?
56 with all the hardware, so your C-post clamps and the water bottle bolts and everything like that is 667 grams.
Sure. Does that give you a little bit of an issue getting it past the UCI's Commissaires?
No, because the UCI doesn't mandate the weight on a frame set. They measure the weight on a complete bike.
Sure.
So it doesn't bother the UCI, it bothers the mechanics, because the mechanics then have to add a whole bunch of lead or steel to the frame. Okay. But it does give them options. You can see that they're using, aluminum bars and stems. They're not trying to optimize the other parts. So it gives them some variety in what they can choose on components.
Sure. There was you were talking a bit before about a resin that goes into that. Can you tell us a little bit more about that?
Yeah, well, the nice thing about California is that it's just an R&D facility, basically. We don't try and make production volumes there. Like, we're only making 350 of these. Yeah. So the nice thing about that is they kind of work with different manufacturers on different projects. And one of the things we worked with, or they worked on, was a group in 3M wanted to look at some new resins. And so they said, we'd like to work with you on it. And they approached us. And this is actually the first time we've found a resin that's really, really good in impact, but doesn't lose any of the other properties. Typically you can get a resin that's been around a while where you can have improved impact properties, sure. But you'll lose them in compression and a few other areas. And so you end up with something that's better in one but worse in other. Yeah, sure. Well, this is actually better in every property, and that's the first time anyone's done that. Downside is it's 7 times more expensive as a material than other carbon fiber, so it's only used pretty selectively in the frame.
Yeah.
But that, and I guess the one thing you can see is the nano nickel that we coated on the steer. And that just combines the best properties of metals, which is ductility. They're very good. We clamp on it with a stem or something like that. It's ductile, so it absorbs the strain. But at the same time, it's got the lightweight carbon fiber interior, so it's very stiff and light. I think we're the next thing for this is we'll take this technology, which is what we do in Project California, and then we'll take that around down through the model range. So you'll see it in the next generation of R5 and R3. You'll see elements of the shapes and the materials, and you'll see those properties improve throughout the model line. That's the whole idea of that California facility, is to learn things and apply them across the model range.